Good afternoon, AP Statistics. Hope you guys are doing all right. It's your favorite AP Stats teacher here, Mr. Ireland. Some people call me MC Ireland. You guys know who I am. So, this is day one of our online distance COVID-19 learning. And we're going to pick up right where we left off on chapter 9.3. If you hear any noises in the background, it's probably my kids running around. I've locked myself in a room, try to keep myself away from them. Luckily, my wife is here to help me out, so should be okay. We're going to try this out, and some of you guys may end up liking this more than actually having me in class. But hey, you know what? We're all adapting, we're all learning, and let's go ahead and get started, shall we? So we are going to move on to chapter 9.3, testing a claim, tests about a population mean. So if you recall, we finished up with testing a claim about a population proportion, and now we move on to population means. So our objective for today is going to be to state and check the random 10% and normal/large sample conditions for performing a significance test about a population mean. And then we are going to calculate the standardized test statistic and p-value for a test about a population mean. If you have your TI calculators, you guys should have those handy. If you don't have one, never checked one out, never got one, you're going to be in a little bit of trouble, but I'll show you some ways to get around it on Staplet. Alright, so let's get started here. So we're going to look at some conditions here. And a lot of them should sound familiar. We've got the random condition, which means the data come from a random sample from the population of interest. 10%, when sampling without replacement, make sure that your sample is less than 10% of your population size n. And then finally, we have the normal and large sample condition, which states that when you sample, your population has to have a normal distribution, or it has to be large. By large, we have to have a sample size of greater than or equal to 30. Or if you have no idea of the shape of the population and it's less than 30, you're going to have to graph the sample data to see if the graph has a normal looking shape. Now, basically what you want to look out for is strong skewness or outliers. Basically the same conditions for a significance test, basically the same conditions as the confidence interval for a mean. Alright, here's an AP exam tip. You know what, I'm going to turn off this pointer because I believe Screencast-O-Matic software already has a highlight tool. But anyhow, it's not enough to make a graph of the data on your calculator. You've got to sketch it if you're doing this for the AP exam. Okay, I've got a 15-minute limit, so I'm going to speed up here. So in this question, we just want to check the conditions to see if we can actually run a significance test. So we have 15 lifetimes for AAA batteries, and we're going to check the conditions. So now, condition 1, is it random? Well, it says it's a simple random sample. It says SRS right here of 15 deluxe AAA batteries. Now, we're going to have to assume, since we don't know the population size, that 15 is less than 10% of all this company's deluxe AAA batteries. Now, notice it's only a sample size of 15, so we are going to have to check the dot plot. Now, what I did is I graphed this data on Staplet. So remember, go to one quantitative variable, single group, and what I did is I typed in battery life, and I typed in all 15 values here, and here's my dot plot. And I can quickly scroll through the histogram. As you can see, nothing unusual about that sample. There are no outliers. If you look at the box plot, same thing here. Looks roughly symmetric. More than roughly symmetric, it looks approximately normal, but again, we're looking for any strong skewness or outliers. Looks good to go. So our conditions are met. Pass on all three. Alright, moving on here. Makers of Chips Ahoy claim that their chocolate chip cookies weigh 11 grams on average. Some hungry AP Stat students wonder if this claim is true. So they took a random sample of 24 Chips Ahoy chocolate chip cookies and found some weights. All right, so pause the video for a second and try to go through those 3 conditions on your own and see if we have them all met. Okay, so random condition is good to go because it said there was a random sample of 24 Chips Ahoy chocolate chip cookies. When the problem says it's random, you assume that it is, so we're good to go. Now, 10%, 24 is less than 10% of all Chips Ahoy chocolate chip cookies. Again, we don't know the population size, but that's safe to assume. Now, again, we've got 24. We don't hit that magic number of 30. So easiest way is to make a quick dot plot of the sample data. Again, I type this into Statlet here. Let me go to this tab. I believe it's this one right over here. Yep, so this is our cookie data. And as you can see, that dot plot looks similar to the one I have on our notes. If you look at the histogram, looks a little funky, but again, you're looking for any strong skewness or outliers. Here's a box plot. Nothing unusual that's going to stop you from proceeding from a significance test. So this one's good to go. All right, moving on. Now we're going to actually go through the significance test and calculate a standardized test statistic. We've done this for proportions. Now we go for means. So for the sake of simplicity, we don't use z-scores when we don't know the population standard deviation. Okay, so just like with confidence intervals, remember, you're going to use the t-table and the t-value and what we're going to call a t-score. Okay, so if you notice a t-score, it's set up just like a z-score. You're going to go value minus mean. The value in this case will be the sample mean that you find. The mean, like the true overall mean, will be this null hypothesis value over here. Your standard deviation is going to be your sample standard deviation divided by radical n. This is what we call the standard error. So all of this you're familiar with, not much that's new. All right? This goes into talking about the t-distribution, which we did when we talked about confidence intervals. And it talks about the degrees of freedom being n minus 1. And the higher and higher your degrees of freedom are, as they approach infinity, you get closer and closer to the standard normal distribution. So at 2 degrees of freedom, looks very, very different from that standard normal. At 9, you see it gets closer to the purple. And the higher those degrees of freedom get, the closer and closer you get to the true normal distribution. We talked about that last chapter when we did our confidence intervals. All right, so you have access to these slideshows. Please go ahead and read up a little bit more on it if you need to. All right, so now this problem says, suppose you want to perform a test of h naught where mu is equal to 5 versus ha, the alternative hypothesis, mu not equal to 5 at the alpha equals 0.01 significance level. A random sample of size n equals 37 from the population of interest yields a sample mean of 4.81 and a sample standard deviation of 0.365. Assume that the conditions for carrying out the test are met. So this first question says, why does the sample result give some evidence for the alternative hypothesis? Well, if you look at the sample mean, it's 4.81, which does give some evidence that it's not 5. Right? Gives some evidence for the alternative because we're saying mu is not equal to 5, and our sample mean here is a number other than 5. So we've got some evidence there. All right, so that's basically the first part. Sample mean is x bar, which is equal to 4.1, which is not equal to 5. That is some evidence for the alternative. Let's get into the standardized test statistic and p-value. So now, again, we're dealing with means. So when you deal with means, you're going to use a t-score, t-value here. All right, so this here, I don't have a tool to write on this, so let me see if I can pull something out here. I don't. Maybe someone can help me with writing tools for Google Slides. I know I can do it with PowerPoint. But just remember, 4.81 is like your value. Value minus mean. And again, the mean is the hypothesized mean of 5. Down here you have your standard error, sample standard deviation 0.365, divided by radical n, which is radical 37. This gives you a t-value, or also called our test statistic, of negative 3.17. So just like a z-score, this is pretty far away from our 0, and you'll get a pretty small p-value as a result of it. Your degrees of freedom are n minus 1, 36 degrees of freedom. Okay, and here is a look, and this is a two-sided test, as you can see, and we've got 2 tails. All right, now on your calculator, what you're going to have to do is you are going to have to look for t-CDF. You can't use normal CDF because we're using the t distribution. So as you can see, what I typed in here is you go on your calculator, you go to second vars, and you look for t-CDF, which is number 6, and you type in the values that you see here. Now, because it's a two-tailed test, I multiplied all of this by 2, and you should get an answer of 0.003. And you've got to type in your degrees of freedom of 36. If you don't do the multiply by 2 part at the beginning, you'll get an answer of 0.00155. Here, I just multiplied this by 2, and it gave me my p-value right away. All right, so if you don't have a calculator, you can actually do this on Staplet. Now, I did not do it with this one, but I'll show you with the next one, okay? Sorry, guys, I'm still trying to figure out my life here with this online learning. Let's try it out with this question here. So, going back to the Chips Ahoy problem, now we want to perform a test of mu equals 11 versus mu is not equal to 11 at the alpha equals 0.05 significance level, where mu is the true mean weight of all Chips Ahoy chocolate chip cookies. The sample had a mean weight of 11.063. So the students and their 24 cookies got this sample weight and this sample standard deviation. We checked the conditions earlier, so we're going to assume that they're met. Why does the sample result give some evidence for the alternative hypothesis? And then we're going to calculate the standardized test. So pause the video for a second and try it out. Okay, so hopefully you pause the video. Why does the sample give some evidence? Well, it's not 11, so we have some evidence for the alternative. Now we're going to go ahead and calculate the standardized test statistic. So here you get your sample mean minus the hypothesized mean of 11, and you divide it by the standard error, 0.562 divided by radical 24, and you get a test statistic of 0.55. All right, so once you get your test statistic of 0.55, our p-value will be found using t-CDF. So you go second vars on your calculator, and again, not normal distribution, but you're going to use not the normal CDF, but t-CDF, and you type in lower 0.55, upper 999, 23 degrees of freedom. This again is a two-sided test, so I'm going to multiply that value by 2, and as you can see, you get an answer of 0.588. That's a pretty high p-value, and we'll get into the conclusion tomorrow. We'll run through the whole SPDC process, and we'll do the whole 4-step problem. All right. There's one more problem I want you guys to try. I'll post the solution to this a little bit later, so look at the slideshow. Identify the hypothesis, check the conditions, calculate the standardized test statistic and p-value. I'm running out of time because I only get 15 minutes to record because I've got the free version of Screencast-O-Matic. So I'm going to wrap it up here. If you guys have any questions, let me know. Give me a message on Google Classroom or Schoology. Have a great day, everybody. I will talk to you guys again tomorrow.